Have you ever spent hours setting up your rig only to realize the target you wanted to image is too small for your field of view? Or worse, you've wasted precious dark sky time hunting for DSO targets that aren't even visible for the time of year or in your light-polluted skies. I'm Morten, and here at my observatory in northern Sweden, I use Stellarium every single imaging session to plan my targets, check field of view, and preview what my targets might look like before I even power on my mount. Today, I'm going to show you the complete Stellarium setup for astrophotography, from basic configuration and adding your equipment specifications to using sky surveys to find the perfect targets for RGB or narrowband imaging. By the end of this video, you'll know exactly how to plan your imaging sessions like a pro. Let's dive in. Well, first things first, if you haven't downloaded Stellarium yet, head over to stellarium.org and select the Stellarium version suitable for the computer that you are using. I'm on a Windows system, and I'm using the latest version, so I'm going to download the Windows 10 Plus version here. There's also a Stellarium web available, but that is far from as powerful as the desktop version, something to consider before using it. When the download has completed, simply double-click on the installation file and follow the instructions on the screen to get started. When you first start Stellarium, it doesn't look like much, but don't worry, we are going to remedy this. But first, we are going to make some basic settings and add your location. In Stellarium, you have two menus in the lower left corner, one down and one to the left. If you move your mouse out there, they will appear, but it also works by using the keyboard short commands like F6, for example, for the location window. Your location settings are crucial because that affects which objects are visible and when. You can search for a location using the built-in search feature, or you can enter your latitude and longitude, and those you can find in any compass app using your smartphone. It's good to be as accurate as possible, so enter latitude, longitude, elevation if you have that. Make sure that you click Use Current Location as default. Enter a name for the location here and add that location to the list in the settings. Next, we are going to open up the basic configuration window. You can do that by clicking on the icon configuration window or F2 if you're using the Windows version. It's good to know that Stellarium is not great at saving settings automatically if you don't tell it to, so please use the Save Settings button here as soon as you have changed any settings in the software, or click on Immediate Save, and that will hopefully store everything you're doing automatically. I'm going to quickly go through the basic configuration of Stellarium here, starting with the information. Here you can deselect displayed fields if you want to. These are all selected by default, and you shouldn't really remove any of them. Moving on to the Extras tab here, I would recommend downloading the additional star catalog updates that are not included in Stellarium for additional stars with a magnitude range that might not be the most visible stars, but still it's nice to have them. So this will have to be done in steps. First of all, the first catalog is not very big. The second catalog also not great, but click through all of the additional star catalogs, download and let them install before we continue. The next step here is the ability to configure the buttons available on the lower left menu here. I usually select compass marks because I want to be able to show a compass here. But the most important buttons has to do with displaying graphics or surveys on the night sky in Stellarium, giving you the ability to see which object or which areas of interest might be the next one you are going to image. Make sure that you select nebula background. That is for the most basic built-in images of the popular deep sky objects. And the two survey buttons, DSS survey and HIPS surveys, because there are a lot of available surveys that will let you display different graphics on the night sky. And I'm going to go into that in depth later in the video here. You can also select the button Observing Lists here, and that will activate a button giving you access to a list of objects that you want to image. The next tab is the Time tab, and here you basically don't have to do anything. Just make sure that you are using the system date and time here, and then select the format that you want to use. Next we have the Tools tab. There aren't any settings, in my opinion, that are crucial to change right away, but you can customize, for example, which font is used to create the information in Stellarium here, if you have a personal preference. You can also choose a default directory where screenshots are saved, if you want to use that feature. Next we have a tab called Scripts, and here you can find some interesting and built-in scripts that you can use, for example, to take a constellations tour of the current sky culture that you're in. These are meant to be used on demand. You don't have to configure anything initially for these. The final tab is Plugins, and here you can select and load at startup some interesting plugins. Most of the ones you need are already selected for load at startup, such as oculars and, for example, satellites and maybe meteor showers, but there are a few here that might interest you, and that is quasars and pulsars. If you want to load these also into the system at startup, you can. There's also a nice one called pointer coordinates, and if you load this on startup, you will get coordinates where you have the mouse pointer at that time, and that can also be useful. That was the basic settings, and now we are going to go into the Sky and Viewing Options window from the left menu here, or by clicking on F4 on your keyboard if you're using a Windows system. In the first tab called Sky, you have some generic sky settings here, and these are all selected by default. You can select the light pollution here, for example, and you can get that automatic from your locations database. That might be good. You can add some shooting stars if you want to. I just find that a little bit distracting, so I don't want to do that. But you can configure on the right side here for the stars in general if you want the stars to twinkle or not. It is twinkle on by default. And you can have spikes in the stars. That is not enabled. I haven't loaded all the stars yet. It is still downloading. As you can see in the lower right corner here, I'm still downloading the Stars 7 catalog. It is at 82% right now. But with the slider labels and markers here, you can drag it to the right if you want to display more stars, even the faint ones. And if you drag it to the left, you will display fewer stars. You might want to include some of the not brightest, but still bright stars if you're considering doing astrophotography and not only visual observations. You can also toggle between use designations for screen labels or not. I prefer not to have that on because it could be a little bit annoying to have to learn the designations rather than the popular names given to the stars here. The next tab is the solar system objects, and here you can configure the solar system. Somewhat in the same way as we did with the sky, you can select labels and markers, even though in the original state you don't have that many objects in the solar system. But you can see here that if I'm increasing this, I will see more of the objects. If I'm dragging it to the left, I will see less of the objects in the solar system. One important thing not to miss here is to click on the Solar System Editor, and that will bring you into the Minor Solar System Objects configuration, and then click on Solar System tab in the middle here. You will see a list of the minor objects that you already have installed on your system, but you can also click on Import Orbital Elements and, for example, select comets, and then select one of the available lists of comets and click on Get Orbital Elements. And mark all and click on Add Objects. You can repeat that if you want for the other bookmarks for comets, just to make sure that you have all of the comets available, because those are something that many are interested in trying to take pictures of. If you want, you can do the same with asteroids, and when you're done, you can simply go back and make sure that all of the objects are in your list, and now you can search for them and find them on the night sky in Stellarium. When you're done, you can simply close that window and go back to the configuration tab for the solar system objects. If you want to mark all the minor bodies in the solar system, you can check the Mark Minor Bodies configuration, but as you can see, you will have a lot of markings on the sky there. Might not be the best thing to have on all the time, so I would suggest not to have that on. The third tab, and maybe the most used for us astrophotographers, is the deep sky objects. And when you click on that, the first thing you have to do is select which of the deep sky objects you want to display in Stellarium. Now the settings here are settings for different catalogs of deep sky objects, and you can toggle them on and off if you want to. I just prefer to select all of the objects here, and then I can choose how many I will display at one time with the same type of settings that we have for the sky or solar system. And that is labels and markers, but you have to activate that. And then you see that you will get a lot of information on deep sky objects here, and you can select how many labels you want to display or how many faint objects you want to display. And the same with the hints here. And the hints, they're basically a green marking for the deep sky objects. If you increase both the label and hints here, you will get a lot of cluttering in Stellarium, and that might not be the best thing to have. So I would suggest keeping these settings down, or especially the hints maybe, because it will still show the brightest objects for you. There are some very useful settings here. You can switch between designations and screen names if you want. For example, you can see NGC 2169 or the 37 cluster here. You can use outlines for big deep sky objects, and that might make them a little bit easier to find here. And again, if you're using sky surveys that we are coming to later in the video, it might not be so nice to have outlines for the big objects. If you want, you can limit which deep sky objects you can see by magnitude, or you can select Show Only Named DSOs, and that will only display the very big and named deep sky objects, and that could also be useful in some cases. You can also activate a filter by type here if you want to display just one type. For example, if I just want bright nebulas here, or if I just want galaxies, for example, I can display that. In my case, I still want to have all of the different deep sky object types, so I'm going to keep all of them checked here. If you want to, you can also configure colors of markers. If you want a certain type of deep sky object to be a certain type of color in Stellarium, you can change that. I haven't really gone down that path yet. I'm keeping everything at default settings for now. The next tab, Markings, and this will let you configure some extra markings. For example, if you want to display the meridian, then I can have a meridian line here going up, and then I will know when the meridian flip will actually occur, and it will give me some idea of how soon or late that will happen. The next tab is the Landscape tab, and in this tutorial I'm not going to dive too deeply into landscapes. I'm using the default here, but you can select one of the available landscapes, or you can download a custom landscape or make your own landscape if you have images and configuration for your exact location. That might be helpful if you want to know how long you can image before an obstruction comes into play. Next tab is Sky Cultures. I'm not going to do any deep dive into this tab as well. I'm using the Modern Sky Culture. I haven't really done any configuration or customization of this. I'm keeping it default as it is, but you can do a lot of configuration here in relation to the constellations viewed in Stellarium. Now we are going to do a deep dive into sky surveys. The main reason for this video today, and here you can find all of the different surveys available to make Stellarium a little bit interesting. Before we move on with the different sky surveys here, please note that the configuration that we did earlier for the menu down at the bottom here have given us 3 buttons related to graphical information and sky survey information in Stellarium, and that is the deep sky objects background images. Then we have the DSS surveys and the HIPS surveys here. We can toggle these on and off. For example, if I enable background images here, I will get some background images that are available in Stellarium by default. And here's an example, the Pleiades here. If I enable background images, I will get an image of the Pleiades here. If I disable that button, I won't see anything. So by default, Stellarium is a bit boring. You hardly see anything when you're zooming in. Yes, you're seeing a lot of designations and different objects here, but you're not seeing actually any graphical information whatsoever. Is there an interesting area that I can photograph, yes or no? So if I click on the background images, that will at least enable some of the objects here, like the North American Nebula here, and here we have some other object, and there are a few other objects as well if I browse around, but it's not super interesting. It's a little bit hard to find them because they're not visible when you're zoomed out. So what can we do about this problem? Well, the first thing we do is that we disable the background images, and then we open up Sky and Viewing Options again, and we click on the Surveys tab. Here you have a lot of surveys. If I didn't know anything, I wouldn't know where to start. But I can start by saying that this is data from different sky surveys. And it's not included in Stellarium, it's actually downloaded from the internet. And sometimes it's not working 100%, sometimes it's a little bit slow. It needs to be downloaded and processed in your Stellarium. So sometimes it can take a while, but if that is the case, you will always get a small progress bar down to the right here, so you can see the progress of the download. So which survey are you going to use then? I randomly was clicking surveys on and off, toggling several at the same time. I didn't get any result whatsoever. Some seem a bit broken or not fetching information like they should. I do need to say that when you have selected a survey, you still need to turn the HIPS or DSS survey on and off. Hopefully it is clear in the description if it is a DSS or HIPS survey, but that's not always the case. I would suggest starting with a series of surveys a bit down in this list called the NSNS, and specifically the one called NSNS DR 0.2 H alpha and continuum. When you click on this survey, it is apparent that this is an HIPS survey. So after selecting this, you can close the window there. We still don't see anything, but that's because we haven't activated. So you simply click on the HIPS survey here and yes. Now, this looks a little bit better than the vast black empty space of Stellarium default. You can zoom in and out, and instead of the blackness, now you actually see all of the interesting areas here. For example, the Spaghetti Nebula here. You can browse through the Orion Nebula. You can identify interesting H-alpha areas that you never knew existed, and you could try to point your camera over to that area to take a nice picture, even though it's not designated as a named object. I can focus on an area up here where the Flaming Star Nebula is. You can see it here, but it's not very clear that this is one object and you have a few others in the same area. What if you want to know exactly what type of data you could gather for each area? Go back into the surveys, remove H-alpha and continuum, and enable one of the other. For example, a single filter channel. Let's say I want to see how much S2 data there is here. Now, this survey only gives me the S2 data, and that could be useful when you're planning your imaging session to see if there is any S2 there. I can do the same for O3, for example. I deselect S2, and then I will select the O3, and then I can identify areas with O3 emissions without being overwhelmed by all of the other data. Another interesting option is also to go and select the H-alpha 8-bit only, and then you can browse around the night sky here and really identify interesting areas like the H-alpha here. There's no big objects here, but there are a lot of H-alpha here. So if I don't know what to image right now, if I don't have an object that is suitable for me right now, I can simply activate the H-alpha here, and then I can zoom out and then browse around the night sky here in search for interesting H-alpha regions to image on their own, maybe, without it being an object. Like these little faint filaments over here, maybe. Yeah, that might be something to do if you already done the most popular objects. What if you're not doing narrowband? Then I would suggest going back into the surveys and select the RGB continuum survey. And that will give you a magnificent view of the Milky Way and other areas of interest on the night sky in RGB, and that will let you point your telescope or maybe your camera and camera lens on an interesting area to get a nice image. You can also identify areas with weak filaments over here or EFN, and that could be interesting for an RGB image, even though it's not in the middle of the Milky Way arc, like over here by the Pegasus cluster. There's a lot of EFN just waiting to be photographed. What if you want to know what exactly fits within your field of view for the camera and telescope combination that you are using? Well, then you can use the sensor frame here. And to be able to use that, you first have to go into the settings here, and here you have to enter information about your lens, sensor, and telescope. I'm using my Skywatcher EvoStar 80ED Pro, and that is not on the list here, so I'm just clicking Add, and I'm typing in Skywatcher EvoStar 80ED Pro, and that is a focal length of 600 millimeters, and it's 80 millimeter in diameter. For that, I'm also using a field flattener and field reducer that I need to add. So I'm typing in field flattener, field focal reducer here, and that is 0.85x. So now I have my telescope, and I have my field flattener reducer, and then I will have to enter my sensor here, and that is the Player One Poseidon M Pro camera. And that is a resolution of 6252 by 4176, and it's 23.5 millimeters by 15.7 millimeters, and I know the rotational angle of my sensor right now because it's fixed. I don't have a camera rotator. Well, I have a manual camera rotator on at the moment, but I rarely use that. So I know that my rotation angle is 121 degrees right now, so I can put that in. You can find this information in Nina, for example, or in the FITS information from a recently taken photograph, but that also stipulates that you haven't changed anything in your imaging train. You haven't removed your camera and put it back or anything like that. It has to be exactly the same as when you took that image. Now I'm finished with the configuration of my telescope and my field flattener focal reducer and my camera sensor, and now I can activate the image sensor frame, and that will display the current view that I would get if I were to point my telescope to this object right now. So this can be useful in framing your objects and figuring out if you need to do a mosaic or if you can actually fit an object into the current field of view for your sensor. It is, of course, good to be able to rotate. Like I said, I don't have a camera rotator right now. I only have a manual one, but that means I have to go out into my observatory in person and rotate. I'm a little bit too lazy for that these days. I will see if I will get an automatic camera rotator or not, but it will still let you figure out which objects are suitable for your combination of camera and sensor. Sky surveys can help you discover areas that you didn't even know about. So let's zoom in to this area in Cygnus, and you can see that we have something called the Cygnus Nebula. It's even called Butterfly Nebula. I haven't even heard about it, but there seems to be interesting HA structures here, and let's just use the sensor overlay to see if this is suitable. And as you can see, it's a perfect match for the telescope and sensor type that I have. So this could be an interesting object to add to my list for a photograph later on. It's amazing how many narrowband targets I've overlooked, because I didn't even know that they existed here. Thank you so much for watching this video, and as always, if you like it, please give it a thumbs up and consider subscribing to my channel if you're not already doing so. Until the next video, I wish you have clear skies.